So, the advantages of looping. Using a loop control variable. Now, that's a really important term, which we'll hit over and over. Nested loops. Then there's avoiding common loop mistakes. Using a for loop. Using a post-test loop. We're going to completely ignore that because our language doesn't support it. Get to Java or C++. And it'll be mentioned again. If the exam, the MindTap test asks about it, just look it up in the book, all right? Characteristics shared by all structured loops. Okay, let's just get into it. So what is a loop? A loop is just code that repeats over and over. Like, say that I need to ask, ask your age. I'm going to add your age. I'm going to write it down. Then I'm going to go to the next person. But I'm going to stop when I reach somebody named Joe. I'm going to come up and say, what's your age? And you tell me, okay, it's 23. So I write down 23. I go to the next person. What's your age? You tell me you're 24. I write that down. What's your age? You're really young. You tell me it's 12. I go on to the next one. I've been forgetting to ask the name. So I'm going to wind up going all the way to the end. What's your name? And you tell me Bob. You're 30. What's your name? You tell me that you're Sam. We go on to the next one. There is no next one. So the loop is done. We had to have had some way of terminating the loop. So maybe when I get to the end here, if you told me your age was -1, I would have stopped. Or maybe something tells me that when I get here and the age was -1, I'm going to stop. There's also counting loops. The counting loop is just what it sounds like. I set a variable x equal to 1, and then my loop says, okay, keep counting until x is equal to 10. I do something with x, I add 1 to it, I check again. X is 2. I do something with it, I add 1 to it, I check again. X is 3. And I do all that until x is no longer less than or equal to 10. So the idea, appreciating the advantages of looping, makes computer programming efficient and worthwhile. I like that. Without loops, programming is not worthwhile. Okay, whatever. Write one set of instructions to operate on multiple sets of data. Less time for design and coding. Fewer errors. Shorter compile time. Alrighty, this stuff's not really resonating with me. Like I said, if the MindTap test asks for it, just go, hit this PowerPoint, read the book. If it asks for the advantages of looping, crib the material from here. The real advantage to it is that you can repeat code over and over and over. I would hate to have to write my code in such a way that I asked, I had 10 input statements in a row. And each input statement had, a conversion and then adding the number together. What would that look like? That would be pretty annoying. If we just did it sequentially, x is equal to input, tell me a number. And then x is equal to the float version of x. And the total is equal to total plus x. And I wanted that to happen 10 times in a row. Alrighty. This is kind of stupid. You can kind of see why that's an idiotic way of doing it. If you have the loop structure. Instead, you do something like this. We want to do that 10 times. We'll use a counting loop. Except I'm not going to call it x. I'm going to say counter is equal to 1. And then while the counter is less than or equal to 10, because I want to repeat this 10 times, I'm going to input x. X is equal to input, tell me a number. I'm going to turn it into a float. And then I'm going to add it to the total. Now, that's not perfect code. But neither was the code up there. Why? Because we never initialized a variable named total. So how could we add to it if we didn't have it in the first place? So if I was trying to make this code really cool and work, I would have to, set the total equal to 0 up at the top. And then I could do that. I could do that stuff. Maybe I'd print it out underneath, right? So why is this stupid besides the fact that I had to cut and paste it, 10 times or whatever? What if I want to make a change to this? What if I want to ask 2 numbers and then add them together before I add them to the total, right? So I come up here and I go, okay, I'm going to ask for float, y is equal to input, and I'm going to convert y to a float, and then I'm going to add, z is equal to x plus y. And then I'm going to, there we go. That looks good to me. So, oh great, now I have to repeat this 10 times. So, okay, yeah, I could copy it. What if we had to add 1,000 numbers together? Would I want that in there? No, I would not want to do that. But you can see what I mean. If I change it here and I want it repeated over and over, I would have to change each block of code that happened after it. 10 times, 100 times, 1,000. Whereas if it's in a loop, I just make the changes in one place. So when it said efficiency, coding efficiency is what's critical. This would run just as fast as this. The program's not going to be more efficient because we wrote it in a loop than because we did it straight sequential. But the coding efficiency is going to be dramatically better, right? If I had to copy and paste this, 1,000 times, rather than just change this to 1,000, it'd be that easy to get it to, run 1,000 times rather than just 10. So that's the idea behind a loop. You create a block of code that you want to repeat over and over and over. And we have flowcharted that before, I believe. Come on. Look like this. What's that? That's an if. What's this? This is an if-else. You can tell it's an if-else because it has two choices. The book calls that a dual alternative. And here's a loop. While x is less than or equal to 10, and then we have, a block of code here. Probably not just one statement, but, a block of code. Ask for x, add it to the total, that kind of stuff. So that's how we flowchart a loop. I'm pretty sure we're all good with that because we have talked about that before. So it's a structure that repeats actions while the condition continues. As long as our counter is less than 10, this code is going to repeat. So there are essentially three kinds of loops. And we'll see if the book calls them the same thing. There are counting loops, or count from 1 to 10, or count from 10 to 1,000, whatever. Then there are user query loops, which is when it works like this. Input X. All right, and then it says input, do you wish to continue? That's one way of finding out when we want to stop. And then the last way is a sentinel value, where you say input X or, -1 to stop. Whatever. That kind of thing. Okay, input X is kind of dumb here. Let's do input a number between 1 and 10. Can I spell number? I always make that mistake. Like that. And then if we're using user query, sentinel value, we would say input a number between 1 and 10 or -1 to stop. That kind of thing. For the user, that would be better because that way they don't have to type in a number and then say, yes, I want to continue, and then type in a number and then say, yes, I want to continue. That takes twice as much input as just saying 10, 20, 30, -1. Right. So those are essentially the three kinds of loops. You ask the user if they want to stop. You ask for a value or use a sentinel value. And when I say ask, we could be reading, from a file or whatever. And then when we hit the end of the file, we consider that our sentinel value. Or you just have a counting loop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to write those three kinds of loops. We're going to do a counting loop first. I just showed you one up there. You initialize a variable. As a matter of fact, we're going to broadly talk about the structure of a loop. A loop does this stuff. Initialize, the loop control variable, and then it tests it, and then it updates it. And that's inside of the test. So essentially all loops are going to do that. You're going to have a loop control variable. You're going to have something that tests the variable. And then you're going to have something that updates the variable. The only time you're not going to have a loop that meets those requirements is if you have a while true loop, which just runs forever until it hits a break statement. But that's a slightly different kind of loop that the textbook doesn't talk about. So if we do a counter loop like that, x is going to be the name of our counter. We're going to initialize it to 1. Did start the recorder, right? Yippee. All right. Then we're going to have our test. While x is less than or equal to 1,000. So that's our test. And then lastly, we do something. I kind of skipped that, but you know, do something good. And then we update the variable. These are the essential parts without which the loop does not work. That thing, and that thing. The do something is gravy, right? The rest of it has to be done. So we have to have these 3 components. We initialize the loop variable, we test it, then we do something useful, whatever that is, and then we have to update it. X equals x plus 1. Or as we like to write it in here, x plus equals 1. But anyways, and that's the update. Textbook calls it something slightly different, like modify or whatever. Whatever. Modify, update, whatever. Why do we have to have the update? Because if we never updated it, x would never stop being less than 1,000 and it would run forever. It's called an infinite loop if you don't update your variable, or you update it in such a way that this condition, this test condition, never becomes false. So that's a counter loop. And the user query loop. We need some kind of loop control variable still, like repeat is equal to y, because we wish to keep repeating. And then while repeat is still equal to y, notice that you use a single equal if you're assigning a value, and you use a double equal if you're comparing. I know we've already said that, but when I walk around and help people, one thing that usually gets 2 or 3 people is because they did that. Okay, so while repeat is y, we're going to do something, and then we're going to ask them if they want to quit. Print, do you wish to continue? y/n. And then we're going to get our input. Repeat is equal to input. Like that. That's a user query. Same process though. We initialized, we tested, and then we updated. Oops, why did I say update and write test again? So that's a user query. And a Sentinel, very similar. Value is equal to something that is acceptable. And the textbook shows you a different way of doing this with what's known as a priming read. And it's okay. But while value is not equal to -1, or whatever your Sentinel value, whatever your stop value is, then do something. But first we need to ask for the value. Value is equal to input. Let's go ahead and print our message on a separate line. Enter your data, or -1 to stop. So we get some input value, we do something with it, but we have to rule out that it's a bad value, whether it's a good value or not. So we do if the value is not equal to -1. Do something with it. And that's it. I haven't been putting our end whiles in our pseudocode. Whatever. This one looks a little bit more complicated to write. Just a little bit. Why is it a little bit more complicated? Because it has a nested structure. It has an if inside the while. But that's okay, really. The textbook shows it a different way. Here's the textbook way of doing it. Sentinel with priming read. And I'll never ask you this, which is value is equal to 0. Ask for the value. Print. Enter your data, or -1 to stop. Then value is equal to input. And then we check. While value is not equal to our Sentinel value, then do something. And then ask them again. Print. Enter your data, or -1 to stop. And then get that value again. Maybe, if you can read the code or the pseudocode enough so that it's easy to spot, maybe you see the key differences between this. If you do a Sentinel value this way, which is my preferred way, you have to add an extra thing in there. You have to add an if statement in here to rule out that they already want to quit, right? Here, you have to have the input code repeated twice. We had to print out that message. We had to get the input. Maybe we needed to convert it. I skipped that step. We did something with it. And then we have our same input code here. So this is what's known as a priming read, or priming input. You get your data, then you have your while loop. And then inside your loop, you ask for your data again. So just like priming a pump, you got to start pumping to begin with before you can start, filling the bucket, whatever. I prefer this method because I don't like having to write the input code twice. And when I say I don't like doing it, it's not that it's a burden. It's that if you ever had to change that code, you'd have to change it in 2 places rather than 1. And I always say if you wind up copying and pasting code, then there's probably a better way of doing it. And in mine, this is the better way of doing it. If you consider writing an if statement more complex, then you might want to do it this way. If you consider writing a print and an input statement more complex, then you'd want to do it this way. Choice is up to you. We know what that is. Loop structure. Here they show looping. And this is actually showing a nested loop. But that's not important. You have your declarations. You do some housekeeping. Are we not at the end of the file? Then loop doing something with the end of the file. This is a predefined function, right? It's a process block with a bar across it. So we're calling some other function, which we didn't write anywhere. And then we come back. So this detail loop is going to be some other loop written inside a module, written inside a function. I guess in Python we'd stick it up here above it, which makes this a nested loop, because this loop is nested inside this one, just like nesting, dolls or eggs inside each other, whatever. And then when the loop is finally is done, because we hit our Sentinel condition of being the end of the file, then we do something at the end of the job. Print done, whatever. Close the file if we had to close the file, if we had opened the file. So as long as the condition remains true, the statements in the while body's loop executes. So you can control the number of repetitions with our loop control variable. The loop control variable is tested, and then the body of the loop must alter. That's their keyword. They said alter, I said update. Potato, potato. If I wanted to make mine look exactly like theirs, I would say alter the variable. I'm comfortable putting updates and then putting in parentheses alters, right? So your repetitions could be controlled by a counter. They could be controlled by a Sentinel value. The difference is that you use a counter when you have a definite series of pieces of data to go through, right? You're going to iterate, 1,000 times. You know in advance how many times it needs to run. You use a Sentinel value or a user query if you don't know how many times it's going to run. You know, the file may be 10 digits long and maybe 1,000 digits long. The user may be, you know, entering 10 test scores or 100 test scores. You don't know in advance. You just want to calculate the average of them. And so you use some kind of signal value or user query to indicate when to stop. But if you knew how many tests there were going to be in advance, you could use a counter loop. So the definite loop is is the one that executes a predetermined number of times. A counter-controlled loop or a counted loop is what they called it. I just condensed that to say counter loop. The loop control variable is altered either by incrementing or decrementing, right? You could go from 10 to 1, those are decrements. You could go from 1 to 10, those are increments. Increment means increase, decrement means decrease. And then the counter usually starts with 0, is what they say here. Okay, yeah, great, but you can start your counter at any value and end your counter at any value. If you want something to repeat 10 times, this is probably how a seasoned programmer would do it. X is equal to 0 while X is less than 10. Do something. Or you can do this. X is equal to 1 while X is less than or equal to 10. Both of those will repeat 10 times. If you count it out on your fingers, as long as you're going less than 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it has done it 10 times. And then when X finally becomes 10, we're done. Same thing here, from 1 to 10. 1, 2, 3, 4, 5, just like we count. 6, 7, 8, 9, 10. Once it goes 1 past that, X is no longer less than or equal. Now you can't mix those. You can't say X is equal to 0 and then run X is less than or equal to 10, or else it's actually going to run 11 times. And you can't start with 1 and then go until it's while it's less than 10, or else you're only going to get 9 iterations. If that's your goal, great. But either one of these will count up to 10. This is called zero-based indexing. And typically, when you use zero-based indexing, you write it as less than the limit. And you could call this one one-based indexing, in which case your while goes less than or equal to the limit. Same way. Now, a user probably doesn't want to see something that says enter test score 0, enter test score 1. But computers usually start counting at 0, which is why I have assignment 0, you know, when we're doing, you know, numbered things, just to try to get you into the idea that, you know, computers start counting at 0. When you're accessing a list or accessing an array, or something like that, then computers tend to use zero-based indexing. So as you continue to program more and more, you will see that more and more often, and you may as well switch your brain over to working to that. But this example is probably a little bit easier to grasp, like when I was working up here. And that's why I showed one-based indexing. Alrighty. I've already talked about a definite loop with a counter. You initialize your counter, and then you have your while. And then something updates, alters, or a sentinel. How about that for something that's easy to read for y'all? They're showing a priming read. Do you wish to continue while you're in? You input that, and if should continue is equal to Y, you output something, and then you ask again, do you wish to continue? That's that priming read structure where, you know, you have your code repeated twice. I'd rather just ask the question once and then have an if statement inside here that said, do you really want to do that or not? And if they chose the sentinel value, then you know, if the value is equal to a valid value, do your work. And then when it comes back up and it checks a while again, if they chose the invalid value, it's done. This is rehashing what I said, a starting value. I said initialize. Test the loop. Alter. I called it update, the loop control variable within the loop. So a nested loop, and this is going to be about where we hit the end of the PowerPoint and we're going to do some coding. A nested loop is a loop within a loop. The outer loop is the loop that contains the other loop. The inner loop is the loop that is contained, right? You have a box inside a box. You order something from Amazon, it comes in a box, you open it, and there's a smaller box. Great. You have an outer box and an inner box. Same with the loops. So I'm going to go back up here. And this is the nested loop right there. It's got an outer loop, right? That's the outer loop condition. It's got an inner loop. That's the inner loop condition. So as long as the outer loop is true, it will jump in here and start doing the inner loop stuff. And then while the inner condition is true, it will keep repeating this over and over. And then finally, when it's done, it's going to come back and check the outer loop condition again. So that would be like if I was adding up the ages of everybody in each row. The outer loop is, as long as there is somebody left in the row. The inner loop would be getting the age of each person. So there's only one person. So my outer loop, yeah, do I have anybody in this row? I sure do. Okay, so I enter the inner loop, get the age, 23. That's great. Is there anybody else in this loop? No, I fall out of the outer loop. Meaning it's time to, excuse me, I fall out of the inner loop and I go back to the outer loop. So I skip to the next row. Are there people in this row? Yep, that was my outer loop test. So we go into our inner loop. Have I counted you yet? Nope. Okay, your age is 28. Have I counted you yet? Nope. Your age is 30. Have I counted you yet? Nope. Your age is 22. All right. Now I am done with my inner loop. There are no more people left in the row. It's time to go to the next row. And I would keep doing that until I am out of rows, right? So notice that this has to work all the way through before the outer loop works again, before this condition is retested. Kind of like counting dollars and cents, right? You have to count 100 pennies before you can add one to your dollar. And then you have to count another 100 pennies before you can add one to your dollar. So that's a flow chart of a nested loop. We can do a little bit of code that looks like that. So I don't know why my sample code for a outer and inner loop did not work. So skip my brain. Sorry, I had a brain seizure here. So let's say repeat is equal to yes. And then we do while repeat is equal to yes. And this isn't the code we're actually going to do. We're going to do a guessing game. We haven't done the guessing game yet where it picks a random number and I'm thinking of a number between 1 and 100. What's your guess? And we guess 20 and it either laughs at us or it says, yes, you did it. We haven't done that right. Okay. That's going to be our example of a nested loop. So, while repeat is equal to yes, we're going to do some work. X is equal to input, give me a number, or -1 to quit. But I'm going to do an inner loop as well. So, while x is not equal to -1, we ask them for that number, x is equal to input, and then we do something with x if it's a valid value. So we have to throw that if statement in there that I mentioned if you skip the priming read step. So if x not equal to -1, then we do something with x. Then we have our end if, we have our end while. Once we're done with this inner loop, we need to ask them if they want to continue. Input, or repeat is equal to input. Continue question mark, y/m. Like that. And then end while. So that's our outer loop right here. This is our inner loop right here. We go through here. Is repeat. Oh, I made my newbie mistake of forgetting to use 2 equals there. My code would not work. I'd sit there and stare at it for quite a while before I finally spotted it. Okay, so repeat is equal to y. While repeat is equal to y. So we drop into the code. We're in our outer loop. So x is equal to 0. While x is not equal to -1. Is that true? Yeah, that's true. So we enter our inner loop. We ask for some data or for a signal value. If it's valid data, we do something with it. And as long this will repeat as long as they don't type in a -1. As long as they don't type in a -1, we repeat the inner loop over and over and over. When they finally do type in a -1, then this is no longer true. It drops out. Then we have the user query here. Do you wish to continue? They type that in to repeat. And if they typed in y, then when it comes back up here and it checks, yeah, they did y. Then we do all this rigmarole again. And if they ever type in anything else other than y, then we fall out of the outer loop. So that's a nested loop example. Are we good with this idea? Okay. Is this good programming? No, I'm not doing it quite right. I'm not putting quotes in it. I'm not converting numbers into floats and stuff like that. But we'll get that to work in our guessing game. So that's what we're going to do. Write a guessing game. It's going to look like this. It's going to say, I'm thinking of a secret number between 1 and 100. What is your guess? They type in 50. And it'll say, wrong. Try again. I'm thinking of a secret number between 1 and 100. What is your guess? Or maybe we want to skip that statement. Maybe that was good enough. What is your guess? They type in 75. And we go, you got it. Done. That's essentially what we want our program to do. Now, just saying wrong, try again is kind of rude. We ought to give them another hint. Otherwise, they're just going to have to guess every single number between 1 and 100. But for now. So what do we have to do here? We have to initialize a secret number. So we have to pick a secret number. And when we first write it, we're just going to set one, to a number we pick, 73 or something like that. And then we're going to have to initialize a guess variable, or declare a guess variable. That's a term we've been using. And then while the guess variable is not equal to the secret number, we're going to ask them to input the guess. And then if the guess is equal to the secret, we're going to print a success message. You got it. If the guess is not equal to the secret number, and yeah, we could use a if-else here, but I'm wording it this way for a specific reason. Print wrong, try again. And then we would have the end of our while, like that. If we really wanted to be awesome, we could ask them if we wanted to play again or something like that. So that's going to be our loop. Now that's not a nested loop, but we could turn it into a nested loop. If this was one module, a module came named game, and then we had something else that called that module. Right? So we declare a variable named repeat, and while repeat is equal to y, we play the game, we call the game module, and then we ask them, input, do you wish to repeat? Like that, right? Now we do have a nested loop. It's just that this one is not nested right here inside this code. Instead, we made it a module. Oh, and I guess we better put a return statement. Hope that makes sense. That's where we're going with this. Pick our secret number. Yeah, that looks kind of like some mutation between pseudocode and whatever. If I wanted to make it good pseudocode, I'd have to bop that over. I wish that they didn't do it that way. Alright, and I could put a star here, and a stop here, stuff like that. That'd make it easier to flowchart. But let's actually code it. So fire up idle. And by the way, what would make it better than just saying wrong, try again?
The number is lower or higher than...
Yeah, we should tell them. Yeah, no, we should say no. Try a higher number, or no, try a lower number. Something like that. And if we really wanted to be generous, we could say no, but you're within 5, or something like that. But we're not going to be that nice, and we're not going to coddle the player. So I've got idle going here. What did I say the very first thing? I'm going to go ahead and just write this part first, and then we're going to write the game module. Maybe I'll put a def game just as a placeholder. So file new. April 4 game. Pardon me? I am so sorry. Why did I say 4? I guess because, yeah, April is 4. Thanks. It is April 5th. La-di-da-di-da. Okay. Guess I'm stuck on yesterday. So here we go. The top of our code was def game. We're going to declare our module. But it's not going to do anything. It's just print game. And then return out of it. We just have to have something there. That's called stubbing out a program. Creating module stubs. Don't know who came up with that term. But there we go. Now we're going to actually do this stuff down here, where we declare a variable name repeat. While the repeat is equal to yes, we call our game module, and then we ask them if they wish to repeat or not. So, start. And then our declarations. You know what, we're only declaring one variable. So, repeat is equal. Do you like uppercase letters or lowercase? Just pick and be consistent through it. Half the problems I find when I'm walking around is somebody made an uppercase Y there, but then when they ask the question, they made a lowercase or something like that. Okay, so while repeat is equal to Y, let's play our game. And then let's ask them again, or let's ask them if they wish to repeat. So repeat is equal to input, parentheses, play again, Y/N. And then end while. We could print OK, done, and then stop. Once you get that far, go ahead and run it. Just to clear out any syntax errors, you know, make sure that we've got it all going. And I have a syntax error. I put a colon in the wrong place. If you typed your colon there, delete it. If you didn't, good on you. There you go. Alright, so it played the game and it's asking us, do you wish to play again? Why? Okay, play again. Okay, this is getting tedious, so I'm finally going to hit no. Okay, done. Alright, so our outer loop works. We've got our outer loop working there. That's our outer loop. We could write the whole game inline right here and make that the inner loop. But I feel like making it a module. So that's why we defined our module up here. Anybody got any syntax errors at this point that you want help with? I sure did. Guess we're all good? Alrighty. So instead of printing game, why don't we say I'm thinking of a secret number? I'm thinking of a secret number between 1 and 100. And if you ever wanted to play this with somebody, you might pick, 10.8 and see if they ever guess 10.8. That'd be kind of violating the spirit, right? But we have to actually calculate our secret number. Now, the right way to do that is to generate what's known as a random number. People use the term random, like I'm so random, meaning, I like so many different things or whatever. But, random is a number that you cannot predict the value of in advance. But I'm going to skip that, and I'm just going to hard code mine to 73. Whatever. Pick your favorite number and put it in there, as long as it's between 1 and 100. And then we need to declare our guess variable. And we have to make sure it's valid, or that at least it does not match the secret value, right? Because if it matched the secret value, then the game would think that it was over. It's only when they actually guess the secret value that we want it to stop running. So let's do our while loop. While our guess is not equal to the secret number, we'll ask them for the value. So, do we want to do it all on one line, or do we want to do it on 2 lines? I kind of like the way it looks on 1 line. So I'm going to do guess is equal to input, parentheses, what is your guess? Question mark. Then we better turn it into a number, because this returns a string and you can't compare a string to this number. So just like we always do, either guess is equal to int parentheses guess, or guess is equal to float. Since we've been using float most of the time, that's what I'm going to do. Bless you. Guess is equal to float guess. Now let's check, see if they got the right value. If the guess is equal to the secret, way to go. Print. Correct. And let's do if guess is, let's go ahead and implement that stuff where it says, whether it's higher or lower. If the guess is less than the secret, we want to tell them to go higher. Print. No. Try higher. And then if the guess is greater than the secret, print. No. Try lower. That's really it. Maybe when we're done with the while loop, we might want to, print something. So that's my end while comment. Why did I type in diff and say end while? That's my end while comment that I want to line up with my while right there. And then I'm just going to print a congratulations message. Congratulations, winner. We're trying to cite them up so that they want to play again. All right, that's our game module. It's possible I don't have any syntax errors. I'm going to find out. All right, I'm thinking of a number between, I know I'm covering the code, just testing it. I'm thinking of a number between 1 and 100. What's your guess? 50. No, try higher. 75. No, try lower. 60. No, try higher. 73. All right, correct. Congratulations, winner. Play again. Yeah. What is your guess? 73. Play again. Nah. All right. Okay, so by some miracle, I did not have any syntax errors. I want to get this part working before we make the change so that we actually get a random number. So there's our code. I'm going to pause the recorder. You can pause the playback if you're watching this on video. And I'm going to do walkabout, make sure that everybody's got it going. So to make a random number, we have to import a library called random, just like we've been importing the turtle library. Import random. And then instead of saying secret is equal to 73, we need to replace that with a random number. Now this is actually what's known as a pseudo-random number, meaning that if it started off at 7, it would always generate the same sequence of numbers each time you called it, because it's a mathematical formula. But we're not going to see any indication of that because it starts off based on a random number generated probably by, the time of day, the number of seconds or whatever. So a pseudo-random number is one that's calculated by a mathematical formula, and that's what we're going to get here. So secret is equal to random dot randint randint parentheses, and we want it to be between 1 and 100, just like that. And if we wanted to cheat, we could tell ourselves what the secret number is. But that really makes it no fun. So I'm not going to add a print statement there that does that. Alright, so I'm thinking of a secret number between 1 and 100. What's your guess? 50. No, try lower. 25. No, try lower. 12. Try lower. Okay, this is wild. 6. Alright. Anyways, I'm going to stop saying this stuff aloud because you're trying your own numbers. Alright, so it took me 1, 2, 3, 4, 5, 6 guesses. Let's go ahead and add the counter so that it tells you how many guesses we've made. So I'm going to declare one more variable up here. Counter is equal to 0, and then every time through the loop we add 1 to the counter. So I just added this line. You don't need to add those stars. I'm just showing you those hashtags. I'm just showing you where I'm making my change. And then counter plus equals 1, or counter equals counter plus 1, however you like to word it. And instead of saying what is your guess, let's include that counter in the words. So to say, enter guess number 1, enter guess number 2, enter guess number 3, and so on. So I just added that statement as well, and I'm going to change my input statement. I'm just going to delete all the green stuff in there. And then I'm going to, whoopsie, enter or input guess number, end quote, comma, and then the counter. And that's not going to really look totally great because it's going, well, I'm not going to make any more changes to that right now. I'm going to run it and then I'll fix it. And what do you know? Input expected at most 1 argument's got 2. That's my mistake. So I should have printed out the counter before I asked them for the input. So I'm going to hit undo, Control Z, until it looks like it originally did. There we go. And instead, I'm just going to print out the counter beforehand. So print round number, end quote, comma, counter. Like that. So we'll say round 1, round 2, round 3, and so on. I'll bring the code back up as soon as I make sure this is worked. Okay, round number 2, round number 3, whatever. Okay, so that's working. So I added this line as well. So far I've had 3 lines that I've added. And I think it would be pretty cool if at the very end it told us how many, right? I mean, they kind of know because, you know, we kept saying round number down here at the bottom. But let's put one underneath the congratulations that says, you know, it took you this many turns. So congratulations, winner, and then on the next line, print, it took you, end quote, comma, counter, comma, quote, turns to win. Period, end quote, in parentheses, like that. Test that out. I guess I should test it out, make sure I don't have a syntax error. Now here's the point where I wish I had made it so that it printed out the secret number, because otherwise, you know, I'm stuck actually trying to win the game. It keeps picking low numbers for me. When y'all tested it, did it pick a number higher than 50?
Yeah.
Okay, good. It's just my weird machine. All right, so I finally got it, and it said it took me 8 turns to win. All righty. We have written our game program. So let's write a few counting loops because that's what the homework is going to be based on. But first I better make sure we don't have any syntax errors. I want you to have the satisfaction of having a working game. All right, let's do a few counting loops. I put the examples in the notes, but I actually want to put them in the code itself. So I'm just going to go up to the very top. And what are we going to do? We're going to count from 1 to 10, the most boring one. Then we're going to count from 20 to 40 by 4s, right? 20, 24, 28, 32, that kind of thing. And then lastly, we're going to count from 40 to 20 by -4s, right? It's going to go back down from 40 to 20. So let's give this a shot. We have to initialize, we have to test, we have to print, and we have to update. So I'm going to initialize with 1 because I said from 1 to 10. And then what's my test? While what? Yeah, while x is less than or equal to 10. That's our test. Now let's do something with it, which is just, in this case, printing it out. And now for our update. X plus equals 1, or if you prefer, x equals x plus 1. They mean the same thing. All right, do this one yourself. Count from 20 to 40 by 4s. You already have a model right here to follow, so ought to be fairly easy. If not, of course, I'm going to do it in a minute anyways. And you could even take a shot at the third one. You probably kind of have the idea. Alrighty, so counting from 20 to 40. X is equal to 20 because I'm starting at 20. While X is less than or equal to 40 because that's my upper limit, I'm going to print X. And then instead of adding 1 to it each time, since I wanted it counted by 4s, yep, X plus equals 4. Or if you like, X is equal to X plus 4. Alright, now this one's got the twist that we're counting down, but it's not that big of a twist. We're going to start X at 40. And then we're not going to do while X is less than or equal to 20. Why is that? Because we're going down, and that's never going to be true, at least not from the beginning, right? If X is 40, it's not less than 20. So we got to make it while X is greater than or equal to 20. So do our stuff with it, and then we're going to subtract 4 from it. X minus equals 4, or if you prefer, X is equal to X minus 4. So it's going to print out some stuff up at the top before it plays the game, but that's no biggie. Let me make sure it works. Alrighty, it's a miracle, no syntax errors. Counted from 1 to 10, counted from 20 to 40, counted back from 40 down to 20. Your homework assignment's the same thing. I just asked for, some loops that print out some numbers, going up and going down. I haven't uploaded it yet, but I will do so pretty quickly after class is done. Alrighty, I want to make a Dropbox for this, so I'm going to cover up the code for just a little bit. And then I'm going to do walkabout and make sure that nobody had any syntax errors or questions. So, pause the recording.